The BluePass system acquires its locations in a very, very quick manner. If we want to search for nearby locations, we simply go to our nearby locations. As you can see, nothing is connected currently. All the vendor or merchant needs to do is plug in a standard inverter. This is an Apple iPhone inverter and our proprietary dongle. That dongle is coded for each merchant. We plug that in, and that's how fast it is. We're going to try that again with our other vendor. That happens to be the coffee shop. Plug in our sushi shop. As you can see, it's almost immediate. And once we've acquired a shop, in this case a sushi shop, we connect, it immediately begins to download all of the merchant data and content, which again is very, very fast. And you can place your order.
Okay.
So we're going to do actual transaction right now, real world transaction, processed through our transaction processor, which at the time is Braintree, although we can work through Amazon, PayPal, any of the transaction processors, which will then be processed through Bank of America, and we're going to illustrate that now. So again, we have our coffee shop in range. As you see, we're going to connect to that coffee shop. We're going to select a number of items here. We can also look at pictures and obviously get descriptions as we've seen before. That's part of the menu. And we're going to select 3 of these, 2 of these, or 3 of these, and we'll add 2 of these. We'll confirm that. And as you see, we go to a confirm purchase. We have a total order of $8.17. The speed with which this is transacted is pretty phenomenal. As you'll see, what happens is this is now going to go to the vendor account, and the order is complete, all in about a second and a half. You can see that all the charges have gone through. There are pending. Settlement doesn't take place until a little later, but they've all gone through and gone through very rapidly. And Fresh Roast Systems, the merchant, has been credited those amounts that were in our records. One of the most important aspects of the BluePass system is our own server software and secure servers. And we've written all of our own software, custom software, where we can control that. And we can basically monitor and administer to many multiple servers. And we need this to basically upload and manage merchant data, transactions, everything. And that's what this is. This is our engine, basically. And that is how we administer and maintain the system. So I'm here with Bob Wynn. Bob is our technical director, programmer, analog and digital expert, and we're just going to do a short discussion on the technology involved with the BluePass system on a more technical level. One of the most important things, Bob, is that we are not using NFC, correct? In using Bluetooth 4.0, Bluetooth Low Energy, Smart Blue, whatever, a lot of different acronyms. What are the advantages?
Well, one, it's all the financial information of the customers are stored on remote servers. So in the event where like the customer loses their phone or gets stolen, the information is still safe remotely. So the person that finds it or the person that's stolen the phone won't have access to that information. And we feel that's pretty important because a lot of times when your credit card gets stolen or lost, you have to immediately report that, right?
Right.
This wouldn't be the case with BluePass.
And what about the speed?
Oh, the speed's fantastic. It's like a 0.3 second handshake.
0.03 seconds?
Yeah, 0.03 seconds. Yeah, so it's very quick.
So 3/1000ths of a second, generally, and The differentiation from other systems, we tried one before, one of the competing systems. In one case, it took 1 minute and 45 seconds just to connect, and then another 40 or 50 seconds to populate the list. How's that possible?
Well, the other technology is using GPS, right? And GPS is very unreliable, and especially in high density, density urban areas where there's a lot of wall, a lot of obstructions. So what happens is that you can't get a lock on your GPS signal, and it takes a while for it to figure it out. And with BluePass, we don't use that technology. We have the option to enable the GPS, but we use a different proximity sensor to figure that out, and that's far more effective for getting a lock on time.
And the range on that, we
about,
found it to be 40 to 50 meters?
Yeah, on our test, it was 40 to 50 meters.
So if you're sitting in a restaurant or in a shopping mall, it'll bring up anything within 40 or 50 meters?
That's right.
In 0.03 seconds?
In 0.03 seconds.
Now, if you can explain a little bit to our watchers how the data transfer occurs, what's going on in sort of a flow from the point of the initial contact of finding the nearby store or merchant right through to the transaction and the completed order.
So when the customer, let's start with the customer's point of view, right? They're walking into the store. What's going to happen is that when they're within range of these BluePass dongles, right? The store will automatically be populated on their phone or their mobile device. So once they see that, they would click on that link, and then it would start populating the menu and everything else. And then after that, they have the decision to pick what they want in the menu, how much of each quantity, and also how much they want to pay gratuity and stuff. And then once that's finished, they confirm the purchase, and then that purchase gets sent to the servers. And then the server does a handshake and then sends that confirmation back to the customer and to the merchant, notifying.
So there's no data kept on the phone?
Absolutely no data.
It's all in the cloud?
Yes.
And the transaction goes through the cloud?
That's correct.
If you could just discuss real quickly the layered technology and what exactly that means, because I don't think a lot of people understand what layered technology is, and then we'll get into some security issues. Right,
so the first layer would be the Bluetooth, or the BOE. So what happens is the customer comes within range, and then the store dongles would trigger the phones, right? It would notify the phones that it's within range. So that's the first layer.
It's actually authenticating both the merchant and the customer.
Yeah, in a way, what happens is the BOE is just transmitting data, so it's giving store ID and all these other pieces of information, right? But it's more of a one-way broadcast. And then once that information is authenticated on the user end, then they retrieve data from the internet, like the store menu, the pictures, prices, and all that come from the cloud. So
the phone's never broadcasting anything?
Yeah.
So no data from the phone, no personal data?
No.
Okay, we've now identified the coffee shop, and we're going to check out the distance. To that shop. As you can see, here's our connection. And here's our dongle. As you can see, it's now gone. And we're back. That was 45 meters, so as you can see, the range is significant, and it's extremely fast. We do not use GPS. This is a proximity sensor combined with two different internet layers through the cloud. The processing is done through a third channel, so it's very, very, very high security. and we access those internet sections in different ways depending on what's available, through 3G, 4G, or through regular Wi-Fi. While we've been looking at the standard application for payments, we've demonstrated the downloading of content and display of menus for merchants. There are a lot of other applications that we haven't discussed. We've already looked into the fact that this could be used for tolls, like an E-ZPass system, but it could bring together all of the different networks without proprietary hardware. All you would need is your smartphone. Because of the speed and the range, it would work quite well. And we have tested that, as a matter of fact, and we do know that that works. There's an amazing amount of ease that presents in connecting these networks, because most of the state networks and actually all the networks in the world for bridges and tolls are not part of the same system. And this would alleviate any need for proprietary hardware. A third application, which hasn't been discussed either, is the nature of our protocol and technology. The dongle that we've created is a hardware interface. In this case, we're using it as a proximity sensor. We've also been able to make it a two-way communication system using DLE 4.0 low power, which would allow us to basically control any analog or digital device, which brings into play industrial controllers and most importantly, healthcare. As a matter of fact, we have addressed attaching it to a glucometer for diabetes monitoring. It then uses the same system going to the cloud to alert primary care physicians, as well as monitor patient. So there's a myriad of applications. The last application we had that we've completed on analog devices is we did attach this to a laser that monitors color in a real-time monitoring system, inline monitoring system actually for coffee roasting, and it becomes a wireless controller and monitor for that laser color system. Now that could be used for any device. It could basically replace an Allen Bradley controller or VFD. So as you can see, there's a great deal of applications that we can address. This is a comparison of speed for finding nearby locations and the connection time. In this case, we're going to compare Square with the BluePass system, and what we'll do is just activate the applications at the same time. Go ahead. And as you see, the BluePass system comes up immediately. And Square is still searching for locations. The menu has already come up on the BluePass system. It's loaded all of the content from the specific vendor. In this case, it's a sushi shop. And we're going to purchase $2.14. The order is complete. Transaction is complete. As you can see, the Square system is still searching for locations. It's now found the locations and is now trying to populate the list. As you can see, it's not ready yet. Now populating. And now we're done. And just to give you an idea of what it looks like on an iPhone versus an iPad, it's basically exactly the same. So just to sum up, what we have here is an extremely fast, easy to use, secure transaction system or control system, depending on the application, and using layer technology, using the cloud, and also allows merchants to interface with their customers on a entirely new level. Entirely new speed, and with more ease than ever before. So it's great.
Yeah, so what we had in mind was to build the system from the ground up, because it addresses a lot of the problems that payment transactions right now, like security being the first one. we wanted to make sure that the system was very safe against hacking, very safe in the event where the user loses their phone or if it gets stolen. So that's the first thing we addressed, right? And then the second thing was the convenience, right? A lot of people get turned off, especially some of these mobile payment systems now where it takes a while to lock in. So we wanted to make sure that the speed was quick enough so the user doesn't get frustrated with the transactions. And also encourage merchants actually with very easy to use tools, kind of made for the 21st century where things are like, everything's online, they can check their data, they don't have to go through many different types of POSs, it's all integrated. So we really took a step back and said, let's build everything from the ground up, and we feel that BluePass fits all the criteria that we set up for the goal. So we believe it's a very good product.
There we go. Fast, easy to use, state of the art.
Yes.
Thanks.